Good morning from the United States, good afternoon and evening around the world. I'm Jim Lane. Welcome to the latest in our series of digest webinars on advanced technology. Thank you to each one of our nearly 500 registered attendees today and those joining us on demand via Channel TV. Welcome to you as well. Today we have Adam Bellimani, the COO of Saola Energy, and Valerio Copini, the VP of Business Development at NextChem. Our topic today is renewable diesel, as you see there, scaled to feedstock. It is a distinct technology and it's a great story. It's a perfect theme for the hottest sector in the advanced bioeconomy, which is renewable diesel, as everyone knows. It's affordable energy with better consequences. It is an opportunity, as we will see today, for technology owners in many countries, and here also in the United States, to create powerful new revenue streams via these heavy-duty energy markets that everyone has been hearing all about. This webinar is being recorded, and this afternoon you will receive a URL to access the recorded version for your offline review. We will be sharing the slides that you are seeing today via the digest shortly. We'll also be taking your comments and questions throughout the hour. Just type those in the white box at the lower left of your screen, and do join in to the conversation. It's good for all of us to connect and to engage on a topic as important as market entries into renewable diesel. With that, Valerio Copini is going to join us first. Thank you, Valerio, for joining us again here in the world of digest webinars and digest online. I'll turn it over to you to begin the presentations.
Thank you, Jim. Good morning, good afternoon, and good evening to all the attendees to this webinar. Thank you very much for the introduction. So yes, today we're going to discuss together with Adam about our renewable diesel solution, and specifically we will also approach two industrial case project that we are approaching in the business development activity and also operating activity. So maybe before entering in discussing about the beauty of our technology and our specific approach to this business, it will be interesting to have a short introduction about ourselves. So NextChem is a company part of MAIRE Group. MAIRE is a large technology and engineering company, historically present in the field of petrochemical, fertilizer, oil and gas. Some years ago, in the intent to lead the energy transition activities, MAIRE Group created the NextChem. NextChem today is focusing on three major businesses. The first one, we call it in a very fancy way, greening the brown. So basically is a decarbonization approach. We do provide technologies in the field of energy efficiency, CO2 reduction, and green hydrogen. The second cluster is the circular economy. We do have a technology solution for plastic recycling and municipal solid waste conversion to chemical and fuels. The third cluster is, let's say, concerning the discussion today, is a cluster that is focusing on creating value from biological feedstock. In this field, we do have a solution in the field of biofuel, and for sure, the renewable diesel is the solution that we propose today to this audience. Maybe Adam, you will go ahead with presenting our Saola and our partnership, please.
Yeah, thank you, Valerio. I appreciate the opportunity, Jim, to talk about this. This is really a topic that we really enjoy talking about. So a little bit about ourselves. We are a technology and engineering company. We are based out of Wichita, Kansas in the U.S. We work mostly in the biofuels area, but we do support customers throughout the globe. With that said, we provide engineering design services, and we also provide some project management for projects that we design. We also have an operations team that provides startup support and commissioning, as well as some O&M activities to support clients that implement our technologies. With that said, as a company, we focus a lot more on the biofuel side of the biofuel side of the bioeconomy. We established a lot of working knowledge with the ethanol industry specifically, but in addition to that, we worked a lot with biodiesel, and we also have a technology in renewable diesel, which we are talking about specifically today. With that said, I'll move on to the next slide and talk a little bit about, what's the difference between biodiesel and renewable diesel. I think this has been covered quite extensively, but then we still get sometimes some questions about, is it really the same? Is it biorenewable? Is it, so sometimes there are still some questions about, what's the difference? So first of all, they're not the same fuel. Biodiesel and renewable diesel are not the same fuel. Biodiesel, or what you call FAME, fatty acid methyl ester, is produced via transesterification. Biodiesel meets ASTM D6751 and is blended with petroleum diesel. So essentially, it's just a blend stock. Most jurisdictions will have a blending limits at 5%, while others will, depending on the time of year, will do up to 20%. On the other side, renewable diesel is a hydrocarbon produced by, in our case, hydrotreating oils and fats. It is a drop-in fuel. So essentially, it is the same fuel that you would get at a gas station, and it does not require any blending. It does meet the ASTM D975 specification for renewable, for petroleum diesel. There are a few differences, a few additional differences as well. Obviously, one of the improvements on renewable diesel is the high cetane number, which is above the 75 range. The other change, or I guess the other characteristic that's worth mentioning, is the cloud point, which in biodiesel, it just depends on what feedstock you start with. As far as the cloud point for renewable diesel, that can be tailored to the market that we are trying to get into. With that said, I'm including here some different pricing trends. On the left-hand side, obviously, we're presenting some trends in Europe. As you can see, renewable diesel has a substantial premium over biodiesel, and that's one of the main reasons is because obviously it's a drop-in fuel. In the U.S., there are programs that are supporting renewable diesel production, as well as other biofuels in general, but specifically renewable diesel has one of the lowest CI scores in the biofuels section for LCFS. With that said, the gap, we talked a little bit earlier about biodiesel versus renewable diesel. That gap can be up to $1 per gallon between the two fuels. And on the right-hand side, I think everybody here, if you follow Jim Lane and the digest, you're fairly aware of the LCFS program in the U.S. The LCFS program in California specifically, but there are others as well throughout the U.S. You have a program in Oregon, and you also have a program in British Columbia that's similar. There is also legislation to support the renewable diesel production and other biofuels as well. There are as recently as this week, there was announced for New Mexico, where there will be a push there. Washington State has also some legislation in the works, and Colorado was one that was announced that they're seriously looking into an LCFS program. So essentially the the future of the market essentially is with the need for lower carbon fuel products is going to increase throughout the U.S. It's not just LCFS in California, although the California is the one that kicked it off. So that's something that I'd like to highlight here as we move forward. Next, here I'm going to talk a little bit about how NextChem and Saola got together to work and provide a solution that is sized to feedstock supply. With our combined offering, we can provide clients with a complete project delivery that fits their available feedstock. We have a focused approach on some pre-engineered sizes, which are 5, 10, 20, and 30 million gallons a year. Although we can do ad hoc sizes as needed, but for the sake of fast project delivery, the standard sizes have been really helpful when we talked with our clients. NextChem will act as a single point of contact for the technology and EPC, and that has having a single point of contract makes the deal easily financeable for developers who are trying to get a project off the ground. And the accelerated project delivery allows them to start generating revenue faster. NextChem provides some of their technology around pretreatment and as well as SMR, and then the Saola side we provide more on the core HDO and ISOM technologies. With that combined under the NextChem umbrella for project delivery, we can offer customers easy approach to execute a project and get off the ground and start generating revenue. With that said, Valerio will cover what makes our model work in the bioeconomy on the next slide.
Thank you, Adam. A lot of people in this webinar, it's used to think with an oil and gas mindset. And at the beginning, also this business of renewable diesel has been, let's say, very much impacted by this, let pass me the word, old approach. In fact, all of us working in the petrochemical field before have experienced the fact that large-scale facilities enjoy better economics. The capital cost per installed ton is lower. When you ask more feedstock to your supplier, normally you receive a better price. But this is not the case when you are working in the biofield. In fact, when you want to aggregate biofeedstock, you are suffering this economy of supply. So basically, more feedstock you want, more you need to collect from a large area, a large geography. Cost of logistic impact drastically the economic of the project. So what we did, in fact, is that after having analyzed carefully these dynamics, we arrive to the conclusion that there is optimum scale for implementing this technology. If you may go, Jim, to the next slide. The reality is that by implementing this approach, we have a feedstock cost that are drastically lower. In parallel, and this is also thanks to the strong coordination and activities that Saola and NextChem made together, we enter into the market with modularized, standardized solution. This gives us the possibility to enjoy both an efficient feedstock approach, with also a very reduced capital cost because our technology is deployed in a very efficient solution that is the modularized and standardized approach. In parallel, thanks to the fact that we can work with lower amount of feedstock, we do select, let's say, the feedstock in order to have advanced feedstock at the inlet of our technology, and this gives the possibility to us to have a very low carbon intensity on our final product. Please, Jim, if you may go to the next slide. This is summarized at the end with this, let's say, list of feedstock that we may utilize in our technology. For sure, we do go to feedstock that are classified as second generation, following the RED 2, or advanced, following the classification in the United States. In parallel, our technology, thanks to the fact that we do have a very efficient approach for what concerns the pre-treatment of the raw material, this gives us the possibility to have a quite wide blend of product. So we are extremely flexible in terms of selection of the raw material. And also our pre-treatment technology gives us the possibility to, let's say, have a very low demand in terms of hydrogen. And this for sure is helping in optimizing the economics of our plant. This technology for sure has been deployed. So this technology exists in the ground, so it's not just an idea that we have in our minds. And in this regard, I pass the ground to maybe we can go to the next slide. I may introduce you briefly, which is the let's say the very high level process flow diagram. So basically, as all the hydrotreating technologies, it is composed by a reaction block that is an hydrotreating reaction, followed by an isomerization, and then at the end by a fractionation, where we produce the product that we want to implement into the market. The feedstock is pre-treated, as I mentioned you before, in order to make it ready for the reaction. And then as chemical, we do introduce in the system the hydrogen, that is, let's say, the molecule that help us in hydrotreating the vegetable oil and in producing the renewable diesel. I would also highlight a very distinctive point of our technology. It is about the fact that our technology is a swinging technology between renewable diesel and sustainable aviation fuel. So we do have the possibility in implementing the NextChem Saola technology to provide to our client a installation that may produce renewable diesel or jet fuel in a campaign mode. This is quite different from what is the situation right now, where sustainable aviation fuel in the large scale facilities is just a byproduct of the reaction. In our case, we may operate the plant in order to make the sustainable aviation fuel as the main product of our plant. Maybe, Adam, you may enter a little bit more in the detail about, let's say, our existing facility in Kansas, because as I was mentioning you before, this is not just a wishful thinking. This is a reality. It's a technology that is working even right now when we are talking. Please, Adam.
Sorry about that. I was muted. I forgot about that. So with that said, thanks, Valerio. The facility that Valerio was mentioning is the one in Garnett, Kansas. So a little bit about this facility. It is co-located with a 50 million gallons a year corn ethanol plant, and it essentially uses the corn oil from the ethanol plant and then imports some additional corn oil for the additional needs that they have. It is the first of its kind bolt-on to be completely integrated with an ethanol plant. So the site has been operational for a while. We are currently scheduling visits, you know, here, Jim, we have that video that showcases a little bit more and gives a little bit more information about the Garnett plant. So if you don't mind, can you play that video, please?
Hi, my name is Adam Belliamani. I am the Chief Operating Officer of Sail Energy. Sail Energy partnered with NextChem in order to further deploy the technology that we developed here in Kansas. The technology is around renewable diesel, and it essentially processes residual fats and vegetable oil into high-quality renewable diesel. So renewable diesel is made with residual fats and vegetable oils. Pretreatment is the first step at a renewable diesel facility. In this step, the contaminants that are in the fats, oils, and greases are removed in order to protect the downstream equipment and mainly to protect the hydrotreating catalyst. Hydrodeoxygenation, or HDO, is the main process at a renewable diesel facility. This is where the renewable diesel is produced from oils and residual fats. The next step is isomerization. In the isom reactor, the cold flow properties of the renewable diesel are improved. The next step is the fractionator. The fractionator is the distillation column for the process. This is where fuel gas is the overhead gas stream. The next product is renewable naphtha, which is a liquid overhead stream, and then obviously the main product is renewable diesel, which is the bottom stream. This is a sample of the renewable diesel product.
Our technology can be scaled to match the supply chain of our customer, allowing them to fully capture the real market value of their feedstock. NextChem make available to the market this technology, the project development support, engineering, procurement, and construction services, as well as training services to ensure the successful deployment of the technology on a worldwide basis.
Thank you, Jim. So let's talk a little bit about our first case study, which, like I said, was implemented using our technology at the ethanol plant. So with us at Sail having a background in ethanol, we believe that this is a great opportunity for other ethanol producers to harness the value of their corn oil and diversify their product stream. And to do that, we were able to harness some of the synergies that are already existing between the ethanol plant and renewable diesel. So, for example, the renewable diesel process is energy long, so that allows us to send some excess energy to the ethanol plant to help reduce their need for natural gas. The other aspect is renewable naphtha, which in the case of corn ethanol plants, it is used as a denaturant, which is a requirement for ethanol plants before they sell their ethanol. They need to denature it. Some other aspects include utilization of some existing facilities and sharing some of the manpower between the two facilities. So so the integration is not just from a technology standpoint. It also includes integrating other aspects from an operational standpoint, and that kind of that's one of the ways to make this case study very appealing for, in this case, ethanol plants. So what does that mean for an ethanol plant? You know, the ethanol field has had a couple of years, a couple of recent years with the very small, if not negative, margins depending on the month. And I think, you know, with our with us being kind of embedded with our clients in the ethanol industry, we kind of understand the struggle that they deal with, and this is why we kind of broached the subject of adding renewable diesel as a revenue diversification subject for them that they should absolutely look into to help them in the long term. So diversifying revenue streams will be critical for the long-term success of ethanol plants, and adding a renewable diesel plant will accomplish that goal. The biorefinery of the future is going to have to break up this what I call a piece of pie, you know, from you know, relying mostly on ethanol to having more pieces and diversify, and to make it as so that they are able to be as competitive as possible. And again, this kind of shows the impact of adding a renewable diesel plant to an ethanol plant. Essentially, you're replacing your distillers corn oil piece with the renewable diesel piece, and then you're not relying as much on your ethanol sales for revenues. To follow the last slide, the revenue diversification strategy is going to allow plants to improve their crush margins. So again, this is, you know, we have some assumptions here on the right-hand side, but this kind of changes all the time. However, what's always clear is that you know, this adding a renewable diesel plant will increase your margins, and thus allow you to stay competitive in the marketplace with all the products that you have that you're selling. Distillers corn oil in this case is an interesting fact because of its low CI low CI score, which we're going to talk about in the next slide here. And this is using the LCFS in California as an example, but then again, most programs have a similar approach to the CI score. So in this case, you know, renewable diesel coming from distillers corn oil is around a 32 CI starting point. We are, even at our lower scale, we're able to maintain that CI score because of how well we integrate with the host plant, which is the ethanol plant in this case. As you know, the CI is impacted by a lot of things, including transportation, electrical mix, things like that. When you're co-locating with an ethanol plant, you're essentially reducing a lot of those additional potential negative CI hits on your plant. So so that's one way to generate to make sure that you have one of the lowest CI scores for your renewable diesel. Obviously, we can use other fats and oils, and here is we're showing what used cooking oil and what tallow is, for example. But our focus is on reducing, specifically for ethanol plants, reducing the distillers corn oil, the CI for renewable diesel coming out of distillers corn oil. Another way to improve on these CI scores is the use of green hydrogen, which Valerio will be covering on this next slide.
Thank you, Adam. Thank you very much. So let's say that we are arriving to the second case study that we would like to present you. We discussed about the feedstock, so the flexibility on the feedstock. We discussed about the fact that our technology is modularized, so well optimized for reducing the capital cost and also optimizing the operating cost of the technology. For sure, as you know, we were talking before, hydrogen is an important component for transforming the fatty acid, so the oil, the tallow, into renewable diesel or sustainable aviation fuel. Let's say that in the large majority of projects that we are implementing, this hydrogen is produced from standard fossil fuel, so basically from natural gas via the steam methane reforming. By the way, we are developing a very interesting project in the United States, actually in Texas, where a very important company in the field of green power generation, Enel, to which belong one of the largest solar plant, about 500 megawatt in the south part of Texas, want to produce some green hydrogen. The point is that the green hydrogen for sure then need an utilization. And we were developing in parallel to this initiative a very interesting project in Texas, nearby to this plant, for transforming tallow, animal fat, also some UCO, into renewable diesel. And this, let's say, is the great synergy between those two projects, because the green hydrogen produced via electrolysis, utilizing solar energy as main feedstock, is then introduced as chemical into the plant for producing renewable diesel, and then the effect is that we do have an ultra low carbon intensity renewable diesel that is actually will be the best in class carbon intensity scoring fuel in the market. So if we go to the next slide, what has been, let's say, our the role of NextChem? The role of NextChem in this project has been for sure a business accelerator, because we do maximize the value for the green hydrogen producer and also the value for the renewable diesel producer by, let's say, putting together two projects that apparently would seem separated, but in reality there is a strong synergy. We do act as project development because in reality we put in contact those two clients. And then, thanks to the great alliance that we have with Sola, but also thanks to the important alliance that we have in the field of the electrolyzer, we give to our client best-in-class technologies in order to, let's say, convert renewable energy in hydrogen and then tallow into renewable diesel. So basically we are, as we like to say, putting together all the elements, so connecting the dots in order to implement the best-in-class solution. Please, Jim, if we go to the next slide, so the scheme of the project is extremely simple. for the green hydrogen, we do utilize only water and renewable energy. Actually, this renewable energy is very low cost for two reasons. First of all, because the plant in Texas enjoy a very sunny geography. Then let's say that the production of this solar facility is very important in terms of hour per year. But also, and this is very important to note, before the green hydrogen plant, a portion of the energy that were generated by the solar plant during the peak hour was not utilized. The system, the electrical system, was not able to, let's say, take this peak of production from the solar plant, and so this energy was lost. By putting this green hydrogen plant, the target is to utilize those peaks that basically are neutral in terms of cost, and then produce green hydrogen plant. Green hydrogen. Then the green hydrogen is transported for only 50 miles into the HVO plant. We put in place a very efficient logistic in order to transport this hydrogen. And then for sure, in the HVO plant, happen the reaction, and we do produce renewable diesel from that. If we go to the next slide, so then we may enjoy, let's say, the level of carbon intensity that we are decreasing, because before Adam was introducing you the carbon intensity that we have for renewable diesel coming from, let's say, the DCO, so the distilled corn oil, utilizing SMR hydrogen, so steam methane reforming hydrogen. In this case, with green hydrogen, we enjoy an additional reduction. We estimate it by an additional 8 to 8 points of reduction. And this gives us the possibility to market, we guess, the most low carbon fuel in the market. Consider that this lower carbon intensity value additional 20 cents per gallon of renewable diesel. I think that we do introduce our technology, we do introduce our value proposition tailored for the, as we say, bringing back the value to the feedstock. We do highlight the reasoning that is behind, let's say, this approach that we have in the market, and also some case study that may be duplicated in other geographies with our technology and with our approach. So I guess, Jim, that we are on time for passing to the question.
Well, thank you, Valerio, and also to Adam for giving us a tremendous introduction to the technology and covering a lot of ground in a very short time. Let's bring up a nice pretty photo of our presenters and a little bit more so you can see them. And I also want to bring in for the round of questions that we have, and we're getting an avalanche of them, which is great. So thank you to all of you getting those questions to us. If you would like to ask one, please pencil it in right now in the text box at the lower left of your screen. That's what that white box is all about, getting information. But Michele Rubino is joining us, the ABLZ Wolfpack industry expert, also an advisor to this partnership here. And Michele, we're getting a lot of questions about feedstock, and one of them asked that noted that the system can handle a lot of feedstocks, but what is the ideal feedstock for this technology? Is there one?
Well, great, Jim. Thanks so much for the introduction, and yeah, I saw a lot of questions about feedstock. The technology is designed to take vegetable oils and animal fats. Vegetable oils can be virgin or can be waste vegetable oils. Chemists will refer to the feedstock as lipids. Things like algal oil definitely is a viable feedstock. I saw questions about waste plastics, MSW. Those are in a different category. In principle, once you have a lipid, a triglyceride, the technology, the core of the process can convert it to renewable diesel. Obviously, in the real world, these feedstocks come with different degrees with contaminants of different types depending on where they come from. So the technology itself is pretty feedstock agnostic. It doesn't really care. It's enough it's a lipid. There's a whole aspect of the front end of the technology around the pretreatment that's meant to really address conditioning the feedstock that's coming in to be suitable for the process. This is not really dissimilar from biodiesel in many ways. There are some differences, at the edges. So in principle, waste oils and animal fats, we really like the low carbon feedstocks because of our business model, because we are designing this value proposition, this offering to be scaled to these very distributed feedstocks. So from a business model standpoint, we believe our offering really is ideal in the context of low carbon distributed waste type of feedstocks where aggregation costs are really high. So those are the feedstocks we prefer, not really because of technical reasons, but because of the nature of that feedstock and where we can really deliver the maximum value with our offering. And technologically, we have all the capabilities to address any pretreatment needs that these varied feedstocks might have.
Michele, while we have you, we've had a couple of questions coming in about costs. Is there anything that we can share on production costs and feedstock and how that compares to, let's say, a large HVO facility? Is this affordable as well as sustainable?
Yes, and this really goes to the core of our value proposition that Valerio and Adam were talking to. Under NDA, we can disclose all the details of the economics of our offering, the KPIs, mass and energy balances. We're ready to engage and provide this type of information. In principle, there is no questioning that economies of scale matter, and so a larger facility will have certain economies of scale advantage over a smaller one. But that said, as Valerio was pointing out, you have to look at the economics, end to end, cradle to grave, as they say. And because especially the low carbon feedstock feeds have big aggregation costs, we believe our offering is end to end the most compelling value proposition for the industry.
Well, we have a lot of questions that have come in, and thank you again for typing those in very quickly. We're going to do a lightning round to try to get through as many of these as we can over the next 13 or so minutes. Let's continue on feedstocks, and Michele, let's also bring in Valerio and Adam if they wish to comment on that. First of all, you mentioned that any type of oil is theoretically usable. Specifically, can you utilize things like waste cooking oil with very high FFA, free fatty acids, those hard to work with feedstocks? Is that a matter of it can work if that's a part of the mix, just different pretreatment? How does that work?
Yeah,
okay, Adam, you go.
Okay, sounds good. Yeah, so in essence, that's the beauty about the HGO process is that it doesn't care what kind of feedstock, on a high level, it doesn't care what kind of feedstock gets fed in. It's all, most of it is related to the pretreatment. So there are certain metals that need to be taken out, the solids, things like that. So FFA content doesn't really matter fact, if it's a little higher FFA, you're actually using a little bit less hydrogen, but that's besides the point. Ultimately, if we know what the feedstock that you want to bring in, and we know the characteristics, the pretreatment can be designed to handle what those feedstocks are. So that's, on a high level, that's kind of a quick summary on feedstocks and this process.
Adam, while I have you, we had, like I said, not only questions about feedstocks, but sort of alternative. I just want to confirm that that when it comes to, let's say, pretreatment, we had a question about what are the catalyst contaminants. You mentioned a few metals, et cetera. What are the worst ones for you, and what are the easiest to handle? What things do we need to look out for as far as the other things that show up in these streams?
Yeah, I guess it just depends. So, for example, one of the I can bring up DCO as an example, which is distillers corn oil. It tends to sometimes have higher phosphorus content. Arsenic is really one of the worst out there, but we don't see a lot of it in DCO. But then on the flip side, you also have you just have another aspect of brown grease. So we have a lot of people that ask us about brown grease, for example, and when we tell them, brown grease is a very loose term, like what one person considers brown grease versus what the other considers brown grease is totally different, and that could be one of the most challenging feedstocks to handle. So.
We had a question about, just to confirm the sort of production size here. Let's say a standard 100 million gallon corn ethanol plant. What kind of renewable diesel facility size would that correlate to, more or less? Adam, I guess that's a question for you.
Okay, say that one more time.
Yeah, 100. Let's say take a standard kind of 100 million gallon corn ethanol plant with the kind of feedstock that's coming in there. How big would a renewable diesel facility that would be located there? What kind of outputs would we be looking at?
Yeah, so for a standard 100 million gallon a year plant, which when you spend enough time in the ethanol industry, standard 100 million basically means 130, 140 million gallons. So you're looking at about 5 to 6 million gallons of DCO extraction. Now each plant is different. I would say that's probably an average. There are some plants that have a better extraction technologies than others. But on average, I will just say 5 to 6 million gallons. So now the ethanol plant will have to bring in about 4 million gallons or so from the outside market. But the beauty about ethanol plants is that if you go to Iowa, in any 100-mile radius, you're probably looking at 3 or 4 ethanol plants relatively easily. So.
We had in our questions about cost, I'm going to ask you about payback time, but also I wanted to, as a secondary question, for those that are interested in signing that NDA and finding out more about the costs, what's the website that's the best place to go to register that interest?
So they can join us in hvo@nextchem.it, and so we will provide the correct, let's say, documentation and answer to their question, documentation for sure, if we will go to an NDA. Anyway, regarding the cost of production, for sure, let's say that when we talk about scale, when we are approaching the small scale, we are in a field in which if you are not sufficiently smart, you will pay a lot of penalties in terms of cost. It is for that when we started approaching the beauty of the small-scale solution, because effectiveness in terms of raw material aggregation, in terms of advanced feedstock, etc. So we study how, let's say, to bypass this problem. And the bypass, let's say, has been the full modularized solution and the standardized solution. What does it mean, standardized? This means that we do have, let's say, products, even if they are technology and plant. So we do have a solution for 5 million gallons per year. We do have solution for 10 million gallons per year, 20 and 30. If a client come to us and ask for 11.5 million gallons per year, our answer will be to either implement the 10 or the 20. The reason for that is because having standardized the solution, we do have a massive economy in optimization, in engineering, in procurement, and then finally in the construction of the plant. The return in terms of economics is extremely interesting. We are talking about 2 digits IRR, and the first digit is not 1 and either 0. Okay, so it's very interesting, and this is due to the fact that our carbon intensity at the end is very low. So our fuel enjoy a better premium in the market for sure. So I am used to say that before our HVO technology, sustainability was equal to cost. So with our technology, sustainability is equal to profit. So a client and a partner that want to implement this technology, so we will not, he will not need to scare about efficiency in terms of economics. And the last but not least, since Saola and NextChem are providing a full solution from the very beginning until the end of the construction and the startup of the plant, so we are, let's say, guaranteeing all the performance of the plant. So this means that there is not the usual separation of responsibility between a technology provider and then a contractor company that build the plant. In our case, we are the same. So at the end, we are a single point of responsibility in the front of the partner.
We're gonna put up a quick slide here for those of you that would like to be in touch with Seol Energy, with Adam Bellimani or NextChem. Larry Copini is here with us today, big team there, and they will answer all the questions for you. So we're going to keep that up for a moment. If you want to contact both, you may find that you're not able to click on both. We'll run that a second time if you wish to be in touch with both. But a quick couple of questions on market before we get to the top of the hour here. We've had a couple of questions about tax credits and things like that. There is in the United States, there's a tax credit associated with biomass-based diesel for some period of time to come. Who gets that? Is it the facility? Is it the producer? How does that get shared?
Again, this is Michele. I'll probably take this one. It depends. There's a number of kind of compliance values. If we're talking about the biodiesel tax credit, the blender takes it, and so typically the producer blends some petroleum and takes that credit. If we're talking about the RINs, there's obligated parties that take the RIN, and they take it at the point of obligation. And similarly for the CI credit in the LCFS. At the end of the day, who takes the credit, I would argue, doesn't really matter, because the value is passed along the supply chain, along the lines of supply and demand dynamics. So we have a good sense of how much the producer is able to capture of the compliance value, be it the biodiesel, the blender's tax credit, be it the RIN or the CI credit, and what the appropriate strategies are to capture, to maximize the compliance value that the producer can capture. We believe our technology offering is all about bringing the value of your feedstock back to you, and that and how you market the product is part of that strategy.
And Kelly, just to follow up there, this particular process, does it currently have approved D4 RIN and LCFS pathways already established?
Yes, the facility in Kansas has both.
Okay. Is that a question perhaps for Adam? Is that facility offer visits? Is it possible to do tours of that facility for interested parties?
Yeah, it is, and we, once we get in touch with the interested parties and have NDAs in place and whatnot, yes, we in fact we encourage having a visit, seeing the facility and running and as well as talking about the integration aspect of it. We're more than welcome it. We really want people to come in and take a look at it. That's for sure. So.
We had a question that we might, as we get close to the finish here, about the competition and what is the competitive edge here. So for this Saola NextChem process, what sets it apart from some other processes that are out there, such as one was mentioned by the questioner, Axen's vegan process, REG's RD process. What sets it apart? And besides the obvious one we've talked about today, is that it's scaled to feedstock.
So I take this point. Personally, I don't like to make comparison with the competition because we are putting on the ground, which is the beauty of our technology, and I think our participant and the people that are joining the webinar are, let's say, free to think about themselves our value proposition. Generally speaking, I think that we have a quite distinctive solution for the feedstock. We have a quite distinctive solution and flexibility in terms of pretreatment of the raw material, in terms of generation of hydrogen, and also in terms of consumption of chemical and energy for producing renewable diesel. So I do think that our effort in order to optimize this technology is at 360 degrees. So I think that to really enjoy the beauty of the technology, we need to go into the detail. And so I really suggest to the people that are participating to this webinar to send us an email to the email address that I give you before, and then it will be our pleasure to come back to you with the right answer and the good curiosities point.
As a final question there, and this pertains to geographies, we've been talking a lot about the particular case example in the United States in corn ethanol, big industry here, but what about other places? Brazil is an increasing area for corn ethanol, and there are other feedstocks available around the world. So what other places might people be sending queries from that would be welcome to see? We have lots of people joining us from around the world today. Valerio, do you take all comers from all countries, or are there particular geographies?
Right now, we are by definition worldwide. So right now we are implementing projects in United States, in different countries in Europe, in Southeast Asia, in India, in South America, also in Africa. So I would say that the globe is our bread and butter, whereas there are raw material available locally, we can implement the project. And this is the beauty also of that, because we don't need to aggregate from 1,000 kilometers. You have a reasonable quantity of fatty acid, we may convert it in a very great product.
Well, basically, almost everyone here today can be a part of that. I would just exclude, somebody mentioned the Omega Algae project, Jonathan Trent's project, which is aimed at building hydrocarbons on Mars. So that probably is not a near-term application of this technology, but everyone else is welcome. As we come to the top of the hour, I want to first of all thank our presenters, Valerio and Adam, for joining us today to give us a look at renewable diesel scale to feedstock. It's an important topic, and here's a way to get into it in a way that makes sense, and you can do well, and you can also do good. So And thank you to all of you, each one of you who has joined us today and making us a part of your day. We're going to be back again for the time with more fresh faces and new technologies and strategies. And until that time, I'm Jim Lane, wishing you a great day and a safe one in the advanced bioeconomy. We'll be sharing slides and more to come this afternoon with links to the on-demand portion recording. And until then, and that email from me with those links, so long. We'll see you next time.